Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 15, threesome. This is a medium level difficulty problem, and we're told that we're given an integer array called nums, and we need to return all the triplets, and such that j, and k are unique. They don't equal each other. However, also that when they all add up to each other, they equal to 0. And we're told that the solution set must not contain any duplicate triplets. So let's look at an example. So we need to find all triplets which equal to 0. So in this example, these two triplets, when added up to each other, equal to 0. And these are the distinct triplets. So these are the two triplets that we return. In this example, the only possible triplet does not sum up to 0. This triplet sums up to 2. So we don't return anything, we just return an empty list. And we're told that we need to return a list because we have a list that we defined here in this return statement. So we know that we need to return a list of triplets. So how can we solve this problem? Well, the naive approach would be using 3 nested for loops, but as you would imagine, that would be n cubed, I believe. So it wouldn't be an optimal solution at all. We'll probably get a time limit exceeded TLE error on Leetcode, and an interviewer wouldn't be happy with that either. So the more optimal solution is to instead find a fixed number. So iterate through our entire list. So iterate through our entire list, and then once we've found a number, let's say we find number 1, and then we have -3 and 2, we can then do, once we've found one number, then we can just do twosome on the rest of the list, excluding this number. So that's basically the problem. The problem is using, doing a for loop and having a nested twosome solution within that for loop, or a more better solution would be to have a 2-point solution. So instead of doing, using a hash map, you can use 2 pointers, sort our list, and then find all the numbers or all the triplets which equal to 0. So let's actually get coding the solution up. The first thing we want to do is create our result list, which is going to be equal to an empty list. And the next thing we want to do is sort our list, like we said. So we're going to say nums.sort, and this is going to sort the list itself and by reference. And then we can say for I in range of length of nums. And now we want to do our 2 pointers. So let's say the left pointer is going to be equal to I plus 1. We want to exclude I itself. And the right pointer is going to be equal to the length of nums minus 1. So we've got our left pointer and we've got our right pointer. And now we're going to say while left is less than right. Now we're just going to do that. We're just going to do the 2-point solution here. So we're going to say while left is less than right. Let's get our total. So our total is going to be equal to left plus right plus I, or j and ki plus j plus k. So we're going to say total is going to be equal to nums I plus nums j, which is going to be nums l, and k, which is going to be nums r. And we're going to say if our total equals to 0, well, we've found a triplet. So what do? We can say result.append and append our triplet. So append I, append L, and append R. If the total is greater than 0, then we want to decrement our right pointer, and then otherwise we just want to decrement our left pointer. And again, if we just do this, we're going to get a infinite loop, because we also want to decrement our pointers when we have found a total as well, because remember, we could have multiple triplets for this fixed number. So we're going to say L plus equals 1, R minus equals 1 as well. Okay, so that's our code there. And what do we do now? Well, now we will have our result list populated, and we can just return our result list. But wait a minute, there is a key sentence here. Notice that the solution set must not contain any duplicate triplets. So this key sentence may catch you out. So how can you solve this problem? Well, instead of using a list, we can use a set, and then we can convert this set into a list. at the end. So instead of add, we're going to convert this into a tuple because we can't have a set of lists. And yes, that looks good to me. Now what do? We're just going to return a list of the set, but remember we can't do that yet because we're just going to get a list of tuples. So we want to instead, we're going to say let's map each tuple to a list object. So or to a list itself, and then we can convert this set into a list. So let's run the code now. And we get a list index out of range. Okie dokie. Total equals nums. Okay. Why are we getting this, guys? We are getting this because we are doing L minus equals 1 instead of L plus equals 1, which is just giving us an out of bounds error. Okay, so the 3 sample test cases pass. Let's check our submission fully passes all test cases. And it does. I had to hold my breath there for a bit. So yeah, that means our solution works. So quite a simple solution, really. We just have to keep in mind that as we, this problem is two problems. It's an outer loop and then doing twosome, or finding the triplet once we found a fixed number. There's 2 steps to this problem, and of course, remembering that we must not have duplicate triplets in our solution set. And another way we could do this is actually saying, instead of having L equal to I plus 1, instead of having a set, we can keep it as a list and check every time we increase our pointers, check if since we've got a sorted list. So let's say our sorted list looks like this. I don't know. We've got 1, 1, 2, 2, 0, 0. Well, every time we come across a number, if that number is equal to this previous number, we just ignore that item in the list, and this will also help us prevent triplets. But it's slightly more harder to wrap your head around, so I just decided to go with this solution instead. So that's all the code needed. In terms of time complexity, guys, we're looking at O of n squared time complexity. We do have 2 loops, both or O of n for the outer loop and then O of n squared for the inner loop. And then our space complexity is going to be O of k, and k is going to be the number of unique triplets in our set. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.